Here is my coursework for section 1. Um, the outer wrap, center of mass, the inner droplet detector, and the droplet counter. So I first start by inputting the video file and put it in a variable. I check whether it was opened successfully or not, and then I define the output as well so that we can see the video. I start with a while loop where I'm starting the video feed. This is where we will have access to each frame of the video. So I first start off with detection of the outer wrap and center of mass, because those two things are connected. So first I convert the frame into a gray image, and then I create a mask that only detects for the color black. This is because the outer wrap is black, and it's the only black color within the frame, so I only want to detect for that. I then inverse the image so that everything else, so that the outer wrap pops out more in the image. I use blur to make the image a bit bolder, because I was not successful in getting the full shape of the outer wrap, but by blurring it I was able to fill in the shape, so it looked much more circular. I then get the edges of the circles that were detected, and then I use hue circles to detect the circles within the images, within the canny image, which only contains the edges of the circular shapes. Here, this is where I draw the circles. So all the circles was put into the circles variable. A for loop goes through this variable, collecting the x, y coordinates and the radius. This line here will draw the outer circle, the outer wrap, and this will draw the center of mass. So what I done was, if I can successfully detect the outer wrap, that means that I'll be able to easily find the center of mass. So what I did was take the x and y coordinates which of the outer wrap and created a small enough, and then I drew a circle, a really small circle with a radius of 1. What this does is that it creates a really small circle that looks like a dot right in the middle of the outer wrap. This essentially is a center of mass detector. Yeah, so this successfully locates the center of mass, because if I successfully am able to detect the circle, then the center of mass should be at the center of the circle. And here for the last line of this is task, I think 3 or 4. This, because I capture all circles in this variable, if I get the length of, if I find the length of that variable, I'm able to see how many circles there are within the image. So what I do is I get the length of the circles array, and then I use put text, the function put text, to write the number of circles within the image. Here lastly is the inner droplet detector. So what I do here is convert again the frame from BGR but now to HSV, because using HSV is more easier to detect colors. Yeah, so what I did was I found the lower bound of brown and the upper bound of brown. What I did was I used a website. I uploaded the image of like one frame, and then I hovered my mouse, and there's these websites the way you can hover your mouse and you're able to see the values of that color. So I got the values, created the lower and upper bound for brown, and then I created a mask. I then invert the image so that everything else, the whole background is white, and the only things that are highlighted is the blobs in the middle. I create a kernel, and then I dilute the image so that the inner blobs become more defined. They become more defined, and then I erode the images so that it becomes more cleaner, so we get a better looking blob that is more circular. After filtering the image, I initialize my blob detector. So I'm not looking I don't use area, convexity, or inertia to locate the inner blobs. I only use circularity because I focused on trying to make the inner blobs as circular as possible by diluting and eroding the image. So this is the upper bound, this is the lower bound of the circularity, 0.6, and the upper bound is here, which is 1. That's the highest we can go. So I pass on eroded images, which is like the most filtered image, and then what I do is draw the blobs. I draw the brown blob location on the original frame, and here the last bit is the output where we can view the results. So here's me playing the video at the start. So here, as you can see, inner blobs being detected as soon as the outer circle is formed. It is detected, and then a green circle identifies the outer wrap. The inner wrap is identified by a red circle, and the center of mass is identified by a green dot. And you can see at the bottom of the video the droplet detector. You can see as soon as one's leaving, it lowers, and then as soon as one's made, it increases. Thank you very much.